Hey guys, so today we're going to be looking at a couple of problems from chapter number 8. So chapter number 8 is about confidence intervals, and the first problem which we are going to be looking at is problem number 46. Okay, so problem number 46 is this electronics company incorporated, and they would like to have a dental plan as a part of their benefits package. And the question is, how much does a typical employee and his or her family spend every year on dental expenses? Okay, so they took a survey. So N is 45, and they wanted to see the mean amount spent was 1820, and the standard deviation was 660. Okay, so the first question is construct a 95% confidence interval. Okay, so let's go ahead and do that. So this was question number 46. So, okay, so your N is 45, and the amount from the sample was 1820, and the sample standard deviation was 660. Okay, so these are the information which we got. And to construct the confidence interval, so what kind of distribution is this? Well, this is a case where the sigma or the population standard deviation is unknown. So when you have a population standard deviation unknown, we use the t distribution. And so in order to construct the confidence interval is going to be x bar plus or minus the t statistic, respective degrees of freedom at the required critical level, and multiplied by the standard error, right? Standard error of x bar. Okay, and that or can be replaced as s divided by n. Okay, so that is the confidence interval, and for us, our critical, we are asked to find out the 95% confidence interval. That means alpha is 0.05. Okay, and or this is on a one-tailed distribution, but for a two-tailed distribution, this 0.05 would mean 5% of the value. That would mean 2.5% on this side and 2.5 on the other side. Okay, so this is going to be 0.025, 0.025. So now that we have that, let's actually write it out. So this is going to be 1820. And what is your degrees of freedom? The degrees of freedom is going to be 4, which is n minus 1. Okay, n is 45. So 1820 plus or minus the t distribution. What's your t value? T value is going to be, let's go ahead and look at the table. T value is going to be 2.0154. Okay, so we're looking at a two-tailed test at 5%, and n is the degrees of freedom is 44, so 2.015. The standard deviation is 660 divided by square root of n. Okay, so this is your answer, and this is your confidence interval. Okay, and so this would give you an answer of, I think, between 1622 is your lower end, and your higher end is going to be 2018. Okay, so this is your 95% confidence interval. Okay, that means when you take this test, when you repeat the sample, 95% of the time the population mean can be found within this interval. Which brings us to our next question. Okay, so the information was given to this president, and he indicated he could afford a $1,700 of dental expenses per employee. Is it possible that the population mean could be $1,700? Okay, and the answer is yes. 1,700 lies between this lower bound and upper bound confidence interval, and this means that 1,700 is a possible population mean. So if your population mean lies outside this interval, that means it's not possible that your population mean is whatever the value which is suggested. Okay, so that's 46. And the next question which I wanted to look is just I picked up another question towards the end of your chapter, hopefully thinking it would be difficult, and it was a little bit of a difficult question. So the next question which you're going to be looking at is question number 64. Okay, so here is the number of, this is a frequency distribution, and here's the number of times ATMs are being used and how often they're being used. Okay, and so the first question, what's the proportion of employees? So here I'm going to use an Excel. I already started working on this, and so there's 30 people who have used the ATM once, and 5 people who use the ATM 5 times, and all these are only for this own companies, for funds employee, yeah, and for fund toy company. And so what is the estimate of the proportion of the people who do not use the ATM? Well, you could just compute the proportion from all this information, and the proportion of the people who do not use the ATM is just 0.25. Okay, and that's your P bar. So this is a proportion question in some sense. As you could kind of train your formulas in the right way. Okay, and so the next question is develop a 95% confidence interval for this estimate, and can nationally sure at least 40% of the employees of fund toy company would use the ATM. Okay, so the 95% confidence interval, if you need to do that, it's going to be P bar. So that is in page number page number 260 is where you could find your formulas for confidence interval for proportions. Okay, so I will just write it out. So the confidence interval for 64 part B, for 64 part A, the answer is 0.25. For 64 part B, the confidence interval is going to be P bar plus or minus, and P bars, whenever you have proportions, you end up using Z distributions. Z into the sigma of P. Okay, or P bar into plus or minus Z distribution into square root of P bar 1 minus P bar by n. Okay, so this is what you try and do for a sample proportion. This is your confidence interval. So technically, you would want to, instead of this, if sigma p is unknown, you use your SP, right? SP, but instead of SP divided by your square root of n, then it becomes 10 error of n. Okay, so this is your updated formula for a sample instead of population, and this becomes your overall formula. So let's write this out. So your P bar is 0.25. And what is your Z value now? Okay, and you could fill up the other parts. It would be 0.25 into 0.75 divided by n. And what is your n? N was 100 employees, for example, over here, sample of 100 employees. And that's this 100 over here. And so what is your Z value? We are being asked for the 95% confidence interval. And if you want to try and find out the 95% confidence interval, you go to your Z table. But the Z value gives you the area under the curve on one side. If you're being asked for the 95% confidence interval, you would need 2.5% on one side and 2.5% on the other side. Or 0.4750 from here, and the same 0.4750 to the other side, cover 95%. So 0.4750 is 1.96. Okay, and that is your Z value, and this gives you your confidence interval. Okay, so that is your answer to part B. And the actual values, I think, are 0.172 and 0.328. So these are your actual values. Okay, and now to answer the second part of the question, can National be sure that at least 40% of the employees of Fun Toys will use the company? What do you think? Our confidence interval is 0.172 to 0.328. So 0.40 is not in this interval, right? So what is this confidence interval? This is the confidence interval of the people who do not use the ATM in a month. Okay? So under the 95% confidence interval, the highest value of people, proportion of people who might not use the ATM is 32.8%. Okay, so National can be made sure that at least 40% of the people will use the ATM. Okay, so that's the answer for the second part of B. And part C, how many transactions does the average fund employee make per month? And to find out the average. Okay, so in order to find this out, you need to go back to your chapter number 3, I believe, just because this is a frequency distribution. Okay, so try and find out the means and medians. Page number, I believe, 97, and page number 98. Okay, so these are your frequency distributions, and let's actually find that out.
Sorry, I don't understand.
Got my phone up my wires still there. Part C. How many transactions the average employee make? Okay. So let's actually find out the product. The product is going to be first employee makes 25 people make 0. And once you compute this, it's going to be sum. So this is your sum product in some sense, which is fx. And the average is going to be this divided by n, just 1.65. So the average transaction is going to be 1.65. And where does this come from? This is just a sample mean, you could call it. Okay, so in terms of a formula, so this is the formula from page number 94. Okay, so your x bar when it comes to frequency distributions, and if you want to try and find out the mean, it's just sigma fx divided by n. Okay, that's your x bar. And now when it comes to sample standard deviation, so that's your part number D. Develop a 95% confidence interval for the mean number of transactions per month. You need to calculate a 95% confidence interval. So that is going to be x bar plus or minus. You can use t distribution or z distribution here because the number of transactions are high. Let's just stick to t. Degrees of freedom alpha into standard error of x bar. That is going to be a confidence interval. And this is 1.65 plus or minus. What's your t value? T value is t degrees of freedom into alpha. Okay, so let's try and use the 70 if possible. And it's 1.994. It's going to be lesser than that. And if you're using the 95% confidence interval, so you're going to use a value of 1.99. Okay, alpha is 0.05. Okay. And then you need to find out the standard error of x. This is the tricky part in this question. And the standard error of x bar is going to be the standard deviation of x bar divided by square root of n. Right? Is s by square root of n. And this s is going to be the formula in page 98. Okay. The formula is actually on page 97, but there's a mistake in the formula, so I'm referring to the formula in page 98. Okay, so s is going to be the square root of sigma f squared minus sigma fx the whole square divided by n and the whole divided by n minus 1. Okay. So in order to do this, you would ideally need to compute everything, like all these tables. That's why I'm doing it in Excel. So x is going to be these values. These are your x values. Your frequencies are this. Fx is going to be f into x. Fx squared is going to be x. And once you have these, what is our formula again? We need summation of fx squared. So the summation of fx squared is going to be the sum of this. And you also need the summation of fx and square that. It's going to be okay, so that's 165 as we computed before, and this is 485. And now we need to the summation of fx, a square of that. And divide by n. And your n is 100. It's 272.25. And so the numerator is going to be 485 minus value. And the denominator is n minus 1. 99. And so the sample standard deviation is going to be square root of numerator divided by the denominator. Okay, so that's your sample standard deviation. So that is S over here. And once you find out your S, is 1.465. We actually substitute it over here. Okay, so your confidence interval is going to be 1.65 plus or minus 1.99 into 1.465 divided by square root of n. Okay, so this is going to be our confidence interval, RT. Okay, so when you actually try and compute these problems, there's the idea of finite correction factor. That's an additional thing which you could apply. Right, so choosing the appropriate sample size, and then there's this idea of finite correction factor. Oh, there it is. Okay, so ideally you add this population correction factor because a firm cannot have like infinite employees, so sometimes this is something which you could kind of add to a population correction factor, and then this would reduce the value by a little bit, but we decided to skip that. So for our class, we'll be using only this as your confidence interval. Okay, so this is your confidence interval without your finite population correction factor. And these values, I'm not sure what the values actually are. Okay, I'll let you compute them. Okay. So, and the last question is going to be last question, is it possible that the population mean is 0? It looks unlikely from the values we got. Okay, so if this lower bound is greater than 0, if this lower bound is a positive value, and the upper bound is also a positive value, that means that 0 is not a possible option. Okay? It's not possible that the population mean is 0. So that's it for this chapter. That's chapter number 8. And, post another video on chapter number 9. So, all right, have a good night, guys. Bye.